Well, hello everyone. We are going to be looking at a new topic. This is the first one in chapter 4, and it's going to be how to solve a system of equations by graph. So, let me kind of take you through what the system of equations are, and then we'll look at how we can solve them and what does it mean to solve a system of equations. Well, a system of equations are equations that typically have two variables. We'll call them x and y. So you might have, for instance, that x plus 2y is equal to 10. And so what you're looking at here is that there are only certain combinations of x and y that if you take the x coordinate and you add 2 times the y coordinate, you get 10. And if we rearrange that, that does become a straight line, which I could graph. But right now, we'll just leave it as an equation. It's an equation with two unknowns, an x and a y. In this case, it happens to be equal to 10. And then you might have another equation, which is, say, 3x plus, say, 4y. And this time, you get the answer, 22. And so in this particular equation, what we have is that 3 times the x coordinate plus 4 times the y coordinate is equal to 22. And that itself would be yet another straight line if we drew it. Now, I'm not going to make any attempt right now to draw the exact value. We can do that in a few moments when we do Desmos. But if you can imagine that maybe the first line looks something like this, and perhaps the second line looks something like that, the two lines will cross, if you're lucky at least, at a single point. And that point is the only place where this is true and at the same time this is true. So when we're solving a system of equations, we're trying to find a value for x, a unique value for x and y, such that the x plus 2y is 10 and the 3x plus 4y is 22. So let's just say, for example, that I tell you that x is 2 and y equals 4. So let's see what that looks like. I'll call this equation 1, just to make it easier to identify, and this is equation 2. So x plus 2y would be 2 plus 2 lots of 4, and that equals 10, and as you can see, it does. And that's equation 1. Now, if I do equation 2, 3 times the x coordinate becomes 3 times 2, plus 4 times the y coordinate, which is that fella. And that's 6, and that's 16, and that equals 22. So we can, and we did, verify that this fella here is our solution. And we normally give the solutions down in WebAssign. They look like this. You're called xy equals, and you're meant to put in this box the x coordinate first, comma, the y coordinate 4. What you're saying here is if you want to solve this system of equations, two equations with two unknowns, the only solution that works is x equals 2 and y equals 4. And that's how you would do it. So we would like to be able to solve equations like this without me just, trial and error until I got one that worked. So how do we do that type of question graphically? Well, we have a nice program which you will be able to get in your canvas called Desmos. And so wait a few moments, I will load that up and we will use it. Here we go. This is what Desmos looks like. And the first equation was x add 2y, and that's equal to 10. And you can see, shrink back a little bit, there's what that one looks like. You then hit enter, and the second equation we had is 3x plus 4y, and that was equal to 22. And that happens to be the green line. Now, if I focus in, right, if I zoom in a little bit, can you see that they cross exactly there? There we go. And can you see that's x2 y4, just like we said it was. So we can solve the system of equations by essentially just plugging two equations into Desmos and finding out the one place where they intersect. And if there is a solution, it will be like this. It will be one spot where the two lines cross, like a skinny X in this case. Now, not all situations generate a unique single answer. So let me now talk about special cases where things don't quite work out the way you would expect or hope. If I did x add 2y equals 10, let's make that my first equation. And my second equation is going to be 2x plus 4y equals 20. You may recognize something about both these equations in this system. These equations are actually connected. If you double this, you get that. Now, what that's going to look like is it's going to be two lines, but they are going to be parallel. So let me show you what two parallel lines are. I'm telling you it's going to be parallel. We're about to find out that that's actually the case. Let's kill these guys off and type in x plus 2y equals 10. And then the second equation is going to be 2x. Well, I'm saying parallel, actually. I think about it. They're going to be more than just parallel. They're going to be identical. Do you see that? I'll move this number out a little bit. You see it? Right, so if I make it 19, and then finally I make it 20, can you see that these two lines are actually the same line? So yes, they are parallel, but they're a little bit of special case. And the special case here is that there's not one solution. There's actually a whole multitude of solutions. In other words, any point you can pick that is on the purple line will work for the black line. So there's, in fact, an infinite number of solutions. Now, suppose the second equation wasn't 20, but it was, say, 10. You see, the difference here is that the two lines are now parallel. Now, there is not any place at all where those two lines will cross over. So in that case, the two lines are parallel, but there are no solutions. So parallel with no solutions, and parallel with an infinite number of solutions. So let's look at some homework questions. And I'll see, I'm not sure if this is going to work, but I'm going to try it anyway. If it does work, I'll be really pleased. Let me reduce this a little bit, that might help. Okay, looks like it might do what I want. So, in these questions, can I shrink this back a little bit as well, probably? There we go. Solved by graphing. Is there no solution? Enter no solution. Right? Use the parameters x and y as necessary. And in this situation, if the equations are dependent, enter the x and y into the values of x and y in terms of x. If the system is inconsistent, enter the words inconsistent. So I'm not quite sure how you could do it in two boxes, but we should be able to do that. So let's try this one here. I'm looking at 3x take away y equals 12. And the second one, 5x plus y equals 12. And it's pretty clear in this case, we agree that there's a solution, and the solution would be 3, negative 3. Okay, let's zoom up and try this one then. This one, the first equation is x plus y equals 1. And this guy here is 3x take away y equals -17. I got, oh, I put that in the wrong place. It belongs over here. 3x take away, oh, I'm being really good today, aren't I? 3x take away y equals -17. And in this case, one solution again. So -4, 5. Let's check that out. So I'll submit answers. Click that off. Submit answer. It works. Already did this one. Got my answer. Yep, here we go. Submit answer. Okay, that one worked. Let's see if I can find one. This one might work. So 2x minus 4y. Let's see what we get when we try to solve this one using a graphing method. So 2x take away 4y equals 2. And y equals x add 2 is the second one. There we go. And there's our solution. -5, -3. And just to double check, we'll do a submit answer. Okay, let's have a look at this one. So they all have the same phrase, solve by graphing. If the equations are dependent, enter x for the value of x and y in terms of the other one. So let's try this one, because I'm pretty sure this one is going to have a problem. And that will come hopefully in a few moments. Here is 5x minus 5y equals 25. And 5x, oh, I wish that was 5y. That's what I thought it said. So that's going to be 5x, take away 3y. And that's going to equal 15. That one has no problems. It's there. So let me create one, because I can't seem to find one of these situations. Imagine that this guy here had in fact been 5. There. Do you see that we have two parallel lines? And when you have two parallel lines, you are going to put in inconsistent. And I guess you put it in that box there. Right? So when you have two parallel lines, you're going to use the word inconsistent. Now, if they happen to be the same line on top of each other, let me show you an example of that and how you would write down your answer if it happened. WebAssign randomizes the questions. So the problem I've got is that the questions you get will be different from mine. And so I get ones that seem to be crossing all the time, but you might, and I'm sure you will, get a couple of lines that are parallel. But let's do a different fella. Let's do a 3x plus 4y equals 10. And then we'll do a 6x plus 8y equals 20. So imagine that was one of the questions that we got. Now, when the lines were parallel and different, as we do, you do inconsistent. So I'm going to try this question now. So let's see what that looks like. I'll do a full screen. So we're going to get 3x add 4y is going to equal 10. And then the other equation was 6x add 8y, and that is going to equal 20. Right, do you see that it's the same guys? If I move this one just a little bit, yeah, can you see it? And then when you make it 20, you get the same line. So we are going to call that situation dependent. right? So when the two lines are equal, right, one on top of the other, you're going to use the word dependent, right? So when that's the first line and the second line, when that happens, we use the term dependent. Now, what they want you to do in the solution, right, is they say put an X in here and then put something there. We'll show you what that is in a moment. It doesn't matter which equation you take, you're going to end up with the same answer that fits in here. We are going to rearrange these equations to be in the form y equals. So this is going to be 3x plus 4y equals 10. Let's use that one. And I'm going to solve for y. So I'm going to take away 3x from both sides. I'm then going to divide both sides by 4. And that gets me negative 3/4 x. And 10 over 4 simplifies down to 5/2. And in this y coordinate, only write that guy down. So negative 3/4 x plus 5/2. And that's what you do when both lines are the same. Now, if you get a question where both lines are parallel, you will write down your answer as basically you're just going to say inconsistent. And I'm assuming you only need to put it in one of the two spots and it will be happy. So hopefully that helps. So let's return back and do a few more of these guys. And who knows, maybe I'll actually get one that's parallel, right? Or maybe I'll get one that's at least dependent, right? That's identical, right? So skip by a couple. That doesn't look like it's going to do any good. That one's not going to be any good. None of these ones, at least none of the ones I'm getting, are going to be that useful. Oh, let's try this one. I think I may get lucky this time. Let's find out. So I'm going to do this question here. And it looks like it's going to be 3x, take away 12y, and that's going to be equal to negative 27. And then this one here is going to be negative x, add 4y, and that's going to be equal to 9. Right, let's put a different number so you can see it. There's 8. 9. There, we got one. Do you see it? So the two lines are the same, right? The purple and the blue are on top of each other. The identical line. We call that dependent. And when it's dependent, you're going to put x here. And then we are going to pick any one of these equations that we like, rewrite it in the form y equals, and whatever we get goes in there. So I'm going to have to return back to the whiteboard to show you what the working is to find that. We have one of the lines is negative x, add 4y equals 9. And I want to solve that or rearrange it as y equals. So I'm going to add an x to both sides. I'm going to divide everybody by 4. So that becomes 1/4 x, and that becomes negative 9/4. And this is the bit, only this bit, not the y equals part. This is the bit that goes in the y coordinate. So I'm now going to return and check this guy out. And here we are going to put 1/4 x and plus 9/4. And submit answer. There you go. That's what you do. And try that one, you'll get a solution. I'm pretty sure that one works. That has a solution, that one works. Right, this is the last one, really. Y is going to equal 1.1x add 2. And the second equation is going to be y equals negative 1.4x, take away 3. Now, that looks like the answer is here. Now, it says use a graphing utility. Well, I've been using it all the time. And it says round off your answers to the nearest hundredth. Ooh. Wonder which one of those two it is. Let's click on it. I think the answer is this number here. It's hard to tell because when you, I could do this. Couldn't I just zoom in? There, that's the way around the problem. Right. You can zoom in by hitting that little button there as well. That's out and in. So you zoom in, and then you just move the mouse pointer. It looks like that guy is negative 2, negative 0.2. So let's check it out. Negative 2, negative 0.2. And I'll do a submit on it. And it was. So do you see when it gets a little bit detailed, if it gets really hard, can't you just zoom in as much as you want and then click the mouse pointer right over the point? Yeah. And it will tell you the coordinates and you write them down. So that is the end of how to solve a system of equations by using Desmos, by doing it in graphically, essentially. So we are finished, and I will see you tomorrow.